You know, it really feels like one day everything was normal and then boom. The next day, the entire world was talking about generative AI. It's this technology that has just completely exploded into the mainstream, seemingly out of nowhere, and it is already changing, well, pretty much everything. I mean, we've all seen the incredible things it can do, right? It's acing some of the hardest professional exams on the planet. It's creating art. It's writing music that feels, well, it feels human. So the big question is, how does a machine actually learn to be that creative? That's exactly what we're going to unpack.
Okay, so before we dive into the really complex stuff, let's start with the absolute basics. What in the world does generative AI even mean? Let's just build a super simple, clear definition so we're all on the same page moving forward.
At its heart, the name really tells you everything you need to know. The artificial intelligence part, that's just a fancy way of saying a computer is doing a job a human would normally do. But the generative part, that is the real magic ingredient. It means it's not just crunching numbers or analyzing data, it's creating something brand new. And the range of what it can create is just staggering. We're talking about everything from emails and essays to photorealistic images, music that could honestly top the charts, super complex computer code, and even video. But for our purposes here, we're really going to focus on text because if you can understand how AI writes, you've got the key to understanding how it does pretty much everything else. Now, here's where things get really interesting. Because while all the hype around generative AI feels like it's brand new, the basic technology has actually been a part of our daily lives for a lot longer than you probably think. Just think about it for a second. When you use Google Translate and it takes a sentence in one language and generates it in another, that's generative AI. And that started all the way back in 2006. When you ask Siri a question and it generates a spoken answer, that's the same idea. Heck, even the autocomplete on your phone that's predicting the next word you're going to type, that's a simple version of this exact same technology. So, that's the big question, right? If we've had this tech for more than a decade, why did it suddenly feel like the entire world changed overnight? What was the spark that caused this huge, massive leap forward? Well, the answer is that there was a quantum leap in just how sophisticated it got. We went from tools that could translate simple phrases or set an alarm for you, to models like GPT-4 that could pass notoriously difficult professional exams, beating the vast majority of human test takers. This was a completely different ballgame. And nothing, I mean nothing, shows this explosion quite like the speed of its adoption. It took Google Translate more than 6 years to get to 100 million users. It took the viral beast TikTok 9 months to do it. ChatGPT got there in just 2 months. The world noticed, and it noticed fast. So, what is the secret sauce here? What's the core technology that powered this incredible explosion in performance? It's time to peel back the layers and take a look under the hood. Okay, so you might not believe this, but this ridiculously complex technology is built on a very, very simple idea. It's called language modeling. And all it's really trying to do, at its most basic level, is predict the next word in a sentence. Seriously, think of it like your phone's autocomplete, but on a superhuman cosmic scale. And here's the basic recipe. First, you feed the model a mind-boggling amount of text from all over the internet. We're talking all of Wikipedia, huge chunks of Reddit, countless books, and so on. Then you use a really powerful type of neural network called a transformer, which is amazing at understanding context. And finally, you train it. For months on end, its only job is to look at sentences, guess the missing words, and learn from its mistakes millions and millions of times. So if the idea is so simple, what changed? What was the big breakthrough? Well, the secret ingredient wasn't some radical new idea. It was scale. Researchers found that if you made these models and their data exponentially bigger, their abilities didn't just get a little better, they exploded. New, almost magical abilities just started to emerge. And just to give you a sense of that scale, let's look at the numbers. A parameter is kind of like a tiny knob that the AI can turn to help it make better predictions. GPT-4 has an estimated 1 trillion of them. That's a 1 with 12 zeros after it. The complexity is just immense. And as you can probably guess, running a training process on a model that massive comes with an equally massive price tag. The estimate to train GPT-4 is over $100 million. And that's just to do it once. At that price, you really don't want to make a mistake and have to start over. But here's the thing.
A giant pre-trained model is just a raw engine. It's incredibly powerful, but it's not ready for prime time. To make it truly useful and safe, you need the human touch. This is a critical step called fine-tuning, where humans actually guide the AI to align with three key principles: make it helpful, make it honest, and maybe most importantly, make it harmless.
And here is a perfect example of that fine-tuning in action. If you ask the AI for a joke about men, it gives you a pretty standard one. But if you ask for a joke about women, it politely refuses, saying it wants to avoid stereotypes. Now that's not a decision the AI made on its own. It's a behavior, a guardrail, that was explicitly programmed into it by human trainers to make sure it stays harmless. So, this level of power and influence obviously brings us to some very, very important questions about the future. It's time to look at the road ahead and really consider both the incredible risks and the mind-blowing potential of this technology.
And the risks are significant, spanning across a whole bunch of areas. Take accuracy. A single factual error from Google's AI literally cost its parent company $100 billion in stock value. Environmentally, these things use a ton of energy. Socially, there are very real concerns about millions of jobs being affected. And of course, there's the one we're all seeing every day, the rise of convincing fakes that make it harder and harder to tell what's real online. So what's the path forward? Well, Sir Tim Berners-Lee, the guy who invented the World Wide Web, has a really pragmatic view on it. He basically says the genie is out of the bottle. The goal shouldn't be to try and stop AI, because that's probably impossible. The goal should be for us as a society to actively work to manage its risks and minimize the potential harm. Which leaves us with one final and pretty thought-provoking question to frame this whole debate. When we think about the massive challenges facing our future, where does this technology truly rank? What's the bigger threat to humanity? Artificial intelligence or something else entirely?